Okay, in section 4.5, we're going to be looking at how to solve logarithmic equations and some different ways we can do that. So a logarithmic equation is just really going to be any equation that contains a log term. So really we're just looking for the word log in an equation. So some examples of this could be something like log base 2 of x equals 7. Or it could be more complicated, log of x minus log of 2 equals log of x plus 3. Anything like that where you have a bunch of logs is something we can solve with a log equation. Now most of the things we need to solve these we already know. We already have most of the skills we need to do that. The only new property we need to talk about is one property of logs where we can actually add and reduce things that have logs. So we'll call this property of a logarithm. If we have m and m that are positive real numbers for some log, if we have m equals n, then log of m also equals log of n. So what this property basically says is if I have two things, whatever they are, that they're positive, I can take the log of both sides. Now this is something we really won't use in this section. We'll really use this in 4.6 where we can take the log of both sides, but it is a pretty helpful property. The opposite is the one that we'll really use in this section, which states if we have the log of m equal to the log of n. Now again, both of these have to have the same base, of course. These are both common logs. Then I can essentially just cancel these logs out and make m equal to n. That's only if I have one log equal to another log. If this is true, then I can use this property. So the nice thing about log equations, at least the log equations we're going to look at, they're basically only two types. The first type is going to use this kind of idea up here where I have a log on each side and I can cancel that log. So we'll call this method 1 where every term is a log of the same base. Now in this case you just have one log on each side. You can have multiple logs, but as long as every term has a log of the same base, we can use this first method. So something like this, if I had log x plus log 2 equals log 7, all those have the word log, so I can use this method. Something like this, log y plus 3 equals log of 4. This one would not be, you cannot do them this way because you have this 3, and that 3 does not have the word log. So if every term has a log, pretty simple way that we can solve these. First thing that we'll do is we will combine the logs on both sides. So if we have multiple logs, then we want to combine them on both sides. Just for fun, we can do this problem that I've written up here. We can bring that down here. We can just kind of do this problem as we work through the steps just to see how it works. So it says we can combine the logs on either side. This goes back to the last section. We talked about the property of logs. So if I want to add log x plus log 2, adding two logs, remember, turns that to multiplication of the stuff inside the logs. So this will get us log of 2x equal log of 7. So now it looks very similar to what we had above, where we have a log on each side. So I can just cancel that log out. So we'll be left with some equation which we can thus solve. So our resulting equation in this one is simply 2x equal to 7, which I can solve just by dividing by 2. So x equals 7/2. Now the most important thing is probably step 4, where you have to check your answer. Because remember, for a log, the domain of a log must be positive. So I can't plug any number in that makes it negative. I can plug in some negative numbers, but only if it's like added to a bigger positive number that makes it positive. You can't ever have a negative inside a log. Let's look at a couple examples using this first method. So this one you'll see, again, this has, every term has a log, 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 log. So I'll first put together anything on both sides. So in this case, I have these two logs I can put together. They're added, so this becomes log of x plus 2 times x minus 2 equals log of 2. Now at this point I have a log on both sides. I can just simply cross that out. So I'm solving x plus 2 times x minus 2 equals 2. So to do this, I'll go ahead and FOIL this. So this is x squared plus 2x minus 2x minus 4 equals 2. So these cancel. So there's no x term, so the easiest way is probably just to get the x squared term by itself. So we get x squared equals 6. So we put the logs together. We canceled out the log on each side, and now I'm solving the resulting equation. So I take the square root, and so x is going to equal plus or minus the square root of 6. But we have to make sure that these both will check out. So if I put positive square root of 6, positive square root of 6 plus 2 is definitely positive. Positive square root of 6 minus 2 is positive because square root of 6 is bigger than 2. So square root of 6 is definitely a solution. I like it. But what about negative square root of 6? Well, negative square root of 6 minus 2 does not work in this one. So the negative root actually does not work. So we only have one solution to this, and it's just square root of 6. So we have to be very careful that if we ever have an answer that it makes it negative, we have to eliminate it. Let's look at another example over here. Now in this case, we actually have lots of logs, but every term has a log, 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 all base 2. So I will put the logs together on both sides. So this will become log base 2 of x times x plus 3 because they're added. On the other side in this case, I get log base 2 of 8 divided by 4 because they're subtracting. So now I can cross out the logs. So I'll get x times x plus 3 equals 2. So if I distribute the x, I'll get x squared plus 3x. And I'll just bring that 2 over. So now I have this equation to solve. So the first thing I'd like to do is I'd like to try to factor it, but there are no numbers that multiply to negative 2 that add to positive 3. So I'm kind of stuck, so I'll have to use my quadratic formula. So negative b plus or minus b squared minus 4 times a times c all over 2a. So that's negative 3. That's 9 plus 8. So this is plus or minus 9 plus 8, which is 17 over 2. So we have two answers. We have negative 3 plus the square root of 17 over 2. And we have negative 3 minus the square root of 17 over 2. Now obviously we should probably check this, make sure that neither of them make it negative. Well, this is a really big negative number, negative 3 minus root 17. So if I look at this first term, which just has an x, I'll definitely have to eliminate that. This one's a positive number, and so if I add 3 to it, it's still going to be positive, so that one's good. So we only have this one solution in this case. Quite honestly, a lot of them will factor, but there are certainly ones like this one where it does not. All right, let's go ahead and look at the second method. What if we don't have every term with a log? So if we don't have it, so method 2 says only some terms have a log. So some do and some don't. So what we'll do is we will combine all the logs, but we'll basically get everything with a log on one side. Then we will combine those logs. So we'll basically have one log equal to some number. Then we can switch to exponential form. Okay, so if you remember the switch between exponential form, b to the y equals x is the same as log base b of x equals y. And so we can use this conversion to switch. Then we'll solve the resulting equation and then check it to, of course, make sure it is a legitimate answer for our log equation, not making it negative. So if I look at this first one, it says solve the following. 4 plus log base 2 of 2x plus 1 equals 7. So there's only one log term, and that's this one, so that's good. But there are two numbers. So I would start this problem by getting rid of that 4. So I'll subtract 4 from both sides. That will get me log base 2, 2x plus 1 equals 3. Now from here I have one log equal to a number, so now I'll just change it to exponential form. So changing to exponential form, remember it's the base to whatever's on the other side of the equal sign equals 2x plus 1. And so now I have to solve the resulting equation. 2 to the third is 8 equals 2x plus 1. I'll take away 1 from both sides. So that's going to give me 7 equals 2x. And then I'll divide both sides by 2. So x equals 7 over 2. Now, does that make the log negative? No, because I'm going to take 2 times 7/2 plus 1. That's definitely positive. So in that respect, I'm good. So the one next to it, log of x minus 3 equals 1 minus log of x. I'll go ahead and get all the logs on the same side. So I'll go ahead and add log of x to both sides. So when I do that, I'll get log of x plus log of x minus 3, the order doesn't really matter, equals 1. So now I have these two logs, so these two logs I'd like to put together. And since they're added, the property says 2 logs added together become 1 log that is multiplied. So log of x times x minus 3 equals 1. So now it is in log form. So now we can switch to exponential. Now, this one doesn't have a base, so remember if there's no base in a log, we assume it to be 10. It's the common log. So when I switch it to exponential, it's 10 to the 1 equals x times x minus 3. And so now I have to solve this resulting equation by distributing the x, getting everything on one side, and solving the quadratic. So this will give me 10 equals x squared minus 3x. Since it's a quadratic, I'll bring everything to one side. So I get 0 equals x squared minus 3x minus 10. We get lucky in this case. This one actually factors, unlike the one above. So we get x minus 5, x plus 2 equals 0. So my two solutions will be 5 and negative 2. But 5 is no problem. 5 minus 3 is positive. 5 is positive. But negative 2 minus 3, no good. I cannot have negative numbers in my log, so I have to eliminate that one. So let's just go ahead and look at some mixed examples that have, lots of different mix of the two types of problems. So this first one we see only has one log. The second one has every term with a log. The next one has all logs, and the last one only has some logs. So again, does it have all logs or some logs? So this first one, since it only has one log, remember, we'll try to get that log by itself and then switch to exponential. So we get the natural log of x plus 1 equals 2. So now we have to change this to exponential form, but there's no base. But remember, a natural log always has base e. So we'll make this e squared equals x plus 1. Now again, e is just some number, so don't be afraid of that. So if we have e squared equals x plus 1, I could just subtract 1. So my answer is e squared minus 1. Now, I don't know what that is, but that is a fine answer. It's definitely positive because e squared is like 2.7 squared minus 1, so definitely bigger than 1. So that's just our answer. If you want to get the decimal approximation, you certainly can. You can plug it in Desmos or any calculator and figure out what e squared minus 1 is. But this is a fine answer. Let's look at the second one over here. Now this one, every term has a log. So remember, this goes back to method 1, where we want to put all the logs together on both sides and cancel the log. Now in this case, before I can put it together, we got this 2 here. So now we'll have to use the property that says if I have a number in front, I can make it an exponent. So I'd make this log base 3 minus log base 3 of 2 to the second equals, and again, we have the 3 over here too, so I could take that up there. So this is log base 3 of 3 to the third. So now I have to still put these two together before I can cancel my logs out, because the only way you can cancel is if you have one log equal to one log. So I have log base 3 of x over 4, because 2 squared is 4, equals log base 3 of 27, because 3 times 3 times 3 is 27. So now these logs will cancel. So we have x over 4 equals 27, which I could solve by simply multiplying both sides by 4. So 27 times 4, 108. So x should be 108. Definitely positive, so no problem having to eliminate it from our solution set here. So this one, this third one, also has lots of logs. So this one will work very similar to the one we just did, except for it's natural log. But again, it's going to cancel the logs because they all have logs. So I don't really care what kind of log it is. So I'll go ahead and I'll bring this half up. So that's going to make it natural log of 25 to the 1/2 power minus the natural log of x equals natural log of 20. So now I have these two logs I have to put together. They are subtracted, so it'll be the natural log of square root of 25, because remember, we're kind of going back and forth with the fractional exponent and the root, but 1/2 power means square root. Square root of 25 over x equals the natural log of 20. Same log on both sides, I can cancel. So I get 5 over x, because the square root of 25 is 5, equals 20. So I would just multiply both sides by x. So we get 5 equals 20x. And then I'll just divide both sides by 20. So x equals 1/4, because 5 over 20 reduces to 1/4. That's positive, so that is a fine answer. Let's look at our last one. The last one says log of x squared minus 1 minus 2 equals log of x plus 1. So here we have two logs and only one number. So my goal is to rearrange this with the logs on the same side and everything else on the other side. So how I'll rewrite this is it's going to be log of x squared minus 1 minus log of x plus 1, because I'm going to subtract it to the other side, so I'm going to subtract that over here, equals positive 2, because I'll, of course, add the 2 to both sides and make it positive. And again, the reason if you only have some terms with log, we get them on the same side, is so we can combine them. So this will be log of x squared minus 1 divided by x plus 1, because it's subtraction, equals 2. So now I can change it to exponential form, and you may also notice inside the log, we have something that factors and actually will work out really nicely. So if I switch it to exponential, it's 2 to the second equals x squared minus 1 over x plus 1. But what I can do to actually simplify this is x squared minus 1 is x minus 1 x plus 1 over x plus 1 equals 100, because 10 squared is 100. So you'll notice we actually have something that cancels out, which makes our equation much easier. So we have x minus 1 equals 100. So always look out for those little things that factor that'll make our life easier. Then we'll add 1, so x is equal to 101. That's definitely positive, so I don't have to worry about any solutions that don't check out. So hopefully this is a nice thing for some log equations. We'll have a couple of assignments to practice some of these before we move on to exponential equations.